Definition of sound. Sound refers to mechanical vibrations that are propagated in the form of sound waves. Amplitude means volume and unit means decibel. The vibration per second is referred to as hertz. So hertz is a very important number for us, and there are different speeds of sound depending on the medium in which sound moves. So sound always needs a medium in which it can move. In air, for example, it's rather slow, 344 meters per second, and in steel, it's 5,100 meters per second. To give you a few examples, thunderstorm is the counting of the seconds between lightning and thunder to determine the distance. And that is the oldest form of sound observation. And then we have the echoes of the mountains, and the phone, the dial tone in the phone vibrates in a frequency of 425 times per second. This is a video, and you can hopefully see the bat flying around, sending out ultrasound signals, and these ultrasound signals are reflected. So it's returned back to the bat. So the bat knows where it's flying in the dark and is not hitting any obstacle in its way. And the same way, it also works with hunting its prey. The bat is sending out ultrasound signals towards the prey is returning it, and the bat can catch the ultrasound. Can catch the prey. Yeah, so the bat is sending out ultrasound signals towards its prey. The prey is reflecting and returning the ultrasound signals back to the bat. The bat knows where the prey is and can locate it and can catch it. And so that is how bats work with ultrasound. And to give you a little bit more information, sound as an information carrier and measurement method. The human ear perceives sound waves in a frequency range from 20 hertz to approximately 16,000 hertz. That means 16 kilohertz. So that's how far we can hear. Everything above is called ultrasound. So the upper limit of 16 kilohertz dropped significant with age. Ultrasound is sound with frequencies above the human hearing frequency range from approximately 16 kilohertz. 20 kilohertz is often defined as the frequency at which ultrasound starts. So you see here, this is the audible sound, which you can hear with your ear, and it goes to 16 or 20 kilohertz, and after that is ultrasound. So with our devices, we are able to make ultrasound hearable and also visible. Usually ultrasound, you can't hear, you can't see, but with our devices, that's possible. A few information in addition to ultrasound. Ultrasound we are measuring is in the high frequencies, and high frequencies are reflected, what you can see here. So the ultrasound is going out, is hitting a barrier, and is reflected in the same angle and in the same way as it arrives. Yeah, so here you see it again. Here you have the ultrasound source, be it a leakage or be it a bearing or a partial discharge. The sound is coming out, is hitting a reflector or an obstacle, and is reflected out in the same angle as it comes in. And then we have the sound wave propagation. So the sound source is here. The closer you are to the sound source, the stronger the sound source is, or the ultrasound is. Yeah, the further you are away, the weaker it is. I hope that is understandable.
Yes, perfect.
Okay, yeah, you know how it works. The question is whether the customers also understand what I'm talking about. So if we talk about ultrasound, for example, and you have compressed air in compressed airlines, you have a leakage in this compressed airline. So the compressed air is floating out of the leakage, is creating turbulences, and these turbulences can be measured with ultrasound. Yeah. So I would like to go to my second presentation, which is the SONASCREEN. I'm not sure, do I have to share this again, or can you see already?
No,
Carlos,
no, you have to share again.
Okay. Here, sorry. So the product which I would like to introduce today is the SONASCREEN 2. This is how it looks like. This is the backside where you have the screen. And to give you a little bit more information, the SONASCREEN 2 has 176 microphones. So in the front or in the back, as you like, you can see here, we have 176 microphones. And the more microphones you have, the easier it is to also find smaller leakages. In addition, we have real-time acoustic results at 100 frames per second. That means when you move the camera inside your workshop or wherever you are, it's a very smooth picture. Our competition sometimes has only 25 frames per second, so when they move the camera, it's interrupted, and doing a measurement, that's not very helpful, as you can imagine. We have a very wide frequency range from 2000 Hertz to 100 kilohertz. As you remember, we said ultrasound starts from 20 kilohertz to 100 kilo, or further to that, but we cover the range from 2 kilohertz to 100 kilohertz. We have a display with a resolution of 1280 times 800. We have 1 terabyte storage, so you can save a lot of your measurements of your videos and screenshots. We have our charging port is a USB-C port. So if you want to use the camera for an extended period of time, you can also use an external power bank to power it up when you are in the field. And then we have an infrared camera integrated. So you have actually both. You have an acoustic camera and an infrared camera inside the same device. It is IP54 protected. We have 4 integrated LED lights and the buttons, which you can see here in the back. You can configure them as you like. You can put in lights on, or you can put in start measurement, or you can put in screenshot, whatever you want to do. That's of course possible as you like. So how does an acoustic camera works? You can see in this picture, here is a sound source, and here is an additional sound source. And here are the microphones, the array of the microphones. So the sound is traveling longer period of time from the sound source towards this microphone compared to this microphone. So in this way, we are able to create a picture which you can actually see on your camera if there is ultrasound sources somewhere around you. I don't want to go too much into details, but this is the basic idea how it works. Yeah, so you can see it here even closer or even easier. So you have a longer period of time for sound to travel to this microphone compared to this microphone here on the complete left. So this is called beamforming, and this is basically how ultrasound in acoustic cameras work. So this is the first display when you start the camera. It's starting up, and you can choose different pre-settings. So we have the Pro mode, which is opening every function. We have the standard mode, which is more for new users who want to train a little bit on the camera, don't know the camera so well. Then we have the presetting compressed air leaks, and we have partial discharge. So basically in applications, two possible applications, compressed air and partial discharge. Here we have the settings, so you can adjust your presettings. You can adjust the frequencies. You can adjust a lot of settings. You can set trigger functions. So if you have an ultrasound coming up and it's very short and you don't know exactly when it is, you can set it up so that the camera is automatically recording and you don't have to wait and maybe you miss the exact moment. It does it for you. Here you have the file manager, so you can open the file manager and find your saved measurements, replay them, transfer them to the memory stick, and so on. That's all possible. Network means the camera is connected to a LAN network. I have connected my camera now to the PC, so that I can show you when I'm done with this presentation how the camera looks like, or how it looks like in real life, and how you find leakages in real life. That's a possibility which you also have. Or if you work in restricted areas where you're not allowed to, as a human being, to enter, you can leave the camera there inside and remote control it with this possibility. We come to leak detection. So leakage is, of course, compressed air, compressed gas, which you do not want to have. It costs money. In compressed air, for example, the compressor needs to work harder. It is using more energy to fulfill the demand of the compressed air users, and that is, of course, what we want to avoid. Here in this picture, you see basically how it looks like. Here you have the screen. Here you have your live picture, and here in the middle, this one here, you see the compressed air leakage. And here you have the spectrogram, where you also will see that you have a higher peak when you find a leakage. And here you have the spectrum in which you will find the audio frequency. On the top right of the picture, you will see a live calculation. How much money are you losing in this leakage, and in euro or in any currency you want to have in liters per minute and in euro per annum. Yeah, but this is all adjustable according to your needs and what you want to do. So that is leak detection. One of the pre-settings we have and one of the main applications we have. The next one is partial discharge. Partial discharge is, for example, in overland lines, when you want to transport energy from A to B, and you have a broken line, and of course you are losing energy with that, and that is what you also don't want to have. So this is the second pre-setting, and you can see here in the lower part of the picture we have a live picture for the PRPD pattern, which helps you to identify what kind of partial discharge is it and how strong the partial discharge is. Last but not least, we have the dynamic range. The dynamic range, you see a lot of writing there on my presentation, but basically it means what kind of strength of ultrasound is the camera accepting. You can adjust this and make it also lower as you need and as you like. So if you want to find only the big leakages or the big partial discharges, then you leave it on the high side. If you want to have all partial discharges or all leakage in one picture, you move it lower and you will find all kind of acoustic phenomena which is available in your area. This is the dynamic range. And basically, when you start your measuring screen, the only thing you need to adjust is the dynamics, and with that you set somehow the focus of the camera. I show this to you in a minute when I do the live presentation. This shows you how to make a measurement. Basically, the camera starts right away to record when you start it. So you just press the stop button and your measurement is already saved then. You can set the savings in a report, so you can export your measurements into the PC, and the PC we give you a software free of charge together with the camera, which then will create a report for you so that you can create a report for the management or for the maintenance crew or for your customer if you're a service company. That is all up to you. And this report then can be printed out and you will find pictures of your measurements. You will find the location of the measurement, and it will also tell you how much money are you losing. Yeah, so this is how you make this measurement. And this is again how you save the measurement. So I just show you a short video which is explaining all that. So you go to the compressed lead mode, and there you will open, can adjust the spectrogram. If you want to have a bigger picture, for example, then you can adjust it accordingly. And you will go to the dynamics. As I said, the more you move it up, the more, also the smaller leakages will be shown. And so you put it rather low, relatively low, and then you will find the normal size leakages. And the square has turned green, so this is in the leakage. And you see here also the calculation. You adjust the distance and put it to report. And the measurement is done, basically. You can put in certain comments in your report. And the first measurement is done. So you're done with the first measurement. And then you found the next measurement, adjusting the dynamics range. And just putting it to report. And that's basically how the camera works. It's a rather easy to use device. You don't need much of a training. For other ultrasound devices, you need much more training and experience and things like that. But for the camera, it's rather easy. So I will now show you how the camera actually looks like. So I think I have to stop this again and open this again. Can you see my screen?
Yes.
Okay. So I showed you earlier how the starting screen looks like. So this is the starting screen. You have standard, professional, compressed air, and partial discharge. And I will now open the compressed air screen and start the camera. So this is now how the camera is recording. And you see there in the back, we have a small testing bench in which we have the possibility to create compressed air leakages. So I just switch it on. And you can see now already I found a leakage here. And sorry, I have to adjust this now with the mouse, so it's not that easy. Usually you do that with the camera. So I go to dynamic mode, and so the dynamics is very low, so I increase it, and you can see quite clearly Here is a compressed air leakage, and it turns green. You can see on the top right of the picture how much loss you make and what how much money you are losing and how many liters per minute you are losing. So this is how easy it is to find leakages with the camera. Once I'm satisfied with my recording, I just press the report button and your measurement will be saved. And then, now I have to turn everything again. Now we call it test, and the recording is saved. And you have, of course, also the option to replay it. First have to stop and then put it to memory. Go to load, go to test, and then you find your measurement again. And of course, you can also replay it here in this screen. You will see always where is what did I do in the measurement. You see here on top the money you are losing, and also the liters per minute. How much are you losing? You have in the same camera also the possibility to use it as an infrared camera. As you can see, I'm changing here. We are now in the acoustic mode, and I'm putting it into the infrared mode. And then I start the camera again, and you can see my hand in front of it, and you can see the colors. Of course, it's not like a 1,000 euro acoustic camera, infrared camera. It's more a possibility which we had. So the camera is mainly an acoustic camera with an additional infrared camera. So it's basically 2 in 1. And that is the main information I wanted to give to you, to give you some information about the camera, and also some basics about ultrasound. Again, it's a relatively easy to use device. You can't do much wrong. Once you are in your in the workshop, you just walk around with the camera. You try to find leakages, and once you have them, you record them. You transfer them to your PC, and you create a report, and then your maintenance crew or whoever can repair. So that's it from my side. Any questions, any things you want to know, then now is the time.
I have one question. What is the maximum dynamic range of the camera?
The maximum dynamic range goes to 20 decibels.
Yes.
But as you can see already now, it's when I put it there, it's very high. So usually you play around a little bit. It depends, of course, also on the background noise, but you have the background noise. You can adjust also with the frequency, but usually you also want to know exactly where the leakage is located. So therefore, I would say you put it maybe between 4 and 5 decibel, and that is okay.
You were always speaking about compressed air, but it works with any type of gas leak.
It works with any type of gas. Of course, some of the gases are more difficult because the particles in the gas are bigger or smaller. So the smaller the particles are, the more difficult it is to find compressed gas leakages. Helium and hydrogen are more difficult to find than other gases, but basically you can also find them. It depends always on the pressure. The higher the pressure, the easier it is to find leakages. For normal compressed air leakages, we need 0.5 bar system pressure, If you have 0.1, it might also work. It depends a little bit on the environment, and maybe you need to try. But 0.5 bar is safe to find leakages.
So it will work also with ammonia or hydrocarbons?
Yeah, we'll work with all gases. The only thing which doesn't work then is the calculation, because the calculation is based on compressed air. So you will find the leakage, but you cannot use the calculation.
Yes.
So here you can also adjust the screen if you want to have a bigger picture, for example. You can adjust the screen accordingly. Now it's, when you want to show something, it's always the same. It doesn't work, but usually it works quite nicely. So that's how it looks like. Basically that's how the camera looks like. You have a few options here. You can put on, switch on the lights, and the camera also comes with a headset, so you can also listen to the audio. But most customers honestly only use the camera because you can see, so you don't need to hear. But for some difficult to find leakages, maybe the audio also helps you.
Could you do a comparison with the traditional air leak detector that has no image at all?
Sorry, say again.
What are the benefits? What are the benefits?
Oh, I think you know, we also have a handheld device, a Sonar phone,
Yes,
and of course you can also find leakages with that one. But for human being, it's easier to see than to listen. So with the camera, you can just walk around, you hold it, and you move in your workshop, and you follow the compressed air lines or compressed gas lines. And then you will find it, and you can see it with your eyes, and that makes it much easier for most humans to work with our devices. And you will have a calculation right away, so that also helps quite a lot. And I think the devices which are only to listen, the handheld devices, they are more going into the bearing and steam trap, so structure-borne ultrasound, and for leak detection, which is airborne ultrasound, it will be more visible, so acoustic camera.
Thank you.
I have one question, Florian. Do we have any automatic report when we finish the measurements for all the measurements you have made?
Well, you can let me go back to the first picture. So here we have the file manager. When you open the file manager, you can create different folders. So you can add here as many folders as you want. Let's call it DMC. And the folder appears here now, and you can put in all the information or all the measurements you made, and then you transfer the complete folder to your PC. The report is created, and you can print it out. So you can differentiate either by folder, or you differentiate on your PC again. That's up to you.
Okay. Okay. Thank you.
Sure.
Alguém tem mais alguma pergunta? É a altura. Florian, it looks like that nobody has more questions. So
that's what I want to hear, because the device is really as easy as I've just shown you. There's not much you can do wrong. Leak detection is the easiest application for ultrasound, and we have also devices for bearing applications, whether you have enough grease inside your bearing or whether you have a crack in your bearing. We have also steam trap testing, whether the steam trap is blocked or not blocked. But leak detection is really the easiest application for ultrasound.
okay.
Yeah. And if you have any questions, please ask Carlos, and I'm sure he will be helpful to answer as well.
I'm going to put this presentation in our YouTube channel, so
Okay.
everybody can look at it later on. And if there are questions, it's just an email or a phone call, and we are here to answer you. Okay.
All right. Thank you, guys.
Obrigado a todos. Boa tarde.
Okay. Bis dahin. Danke. Tschüss.
Thank you. Thank
Bye-bye.
you. Bye-bye.
Bye.